In this section, we're going to discuss a case study using arithmetic operators. Most computer systems measure their current time based on January 1st, midnight 1970. Might seem a strange time, but that was picked many years ago. That's called the epoch time. Since then, the number of seconds is used as a single number that represents time. So after midnight, there was 1 second, then two, then three, and on up to the current time, which are many millions of seconds. The reason for that is that it's easy to compare two integer numbers. Technically, these are longs. An integer does not hold a sufficiently large number to do this well, so a long is used. To compare if a time is greater than a different time, if it comes after or if a time comes before, we just measure two long values and determine which one's bigger. As the case study goes on, we'll see that not using this scheme is rather difficult. Using the seconds, minutes, hours, etc. becomes very hard. Most computers measure their time in milliseconds. That is 1/1000th of a second. Because they operate so rapidly, the duration of 1 millisecond is rather large for most CPUs. So it's an easy time unit for them to work with. Perhaps our minds don't grasp a millisecond well. That's okay. That's why we have machines. Java provides a method to obtain the current time. It is a method of the system or the machine itself. That makes sense because the computer's motherboard maintains a clock, as does the CPU. The system.current time millis. Notice that camel casing. First letter of the method, current time millis, is lowercase. Each subsequent word is uppercase. It returns a long value, returning right now in milliseconds since that epoch time. So if we did it today, we would get a large number, an integer number stored in a long, and that would be the number of milliseconds. Now, if we divide those milliseconds by 1,000, that will yield the total number of seconds since epoch time. For those that are astute with their mathematics, you realize if we take the number of milliseconds and just simply divide as an integer by 1,000, there may be a number of milliseconds that get chopped off. That's part of what we're going to deal with, the idea of finding those parts that are going to be left over. For example, let's say the number of milliseconds came back as 1,005, some large number, 1,000, and then 5 milliseconds left over there. When we do that integer division, those 5 milliseconds will be dropped off. We're not going to remember that remainder because an integer has no decimal portion, so those will just plain old be lost. Given those total seconds, after we do the division by 1,000, we're going to do a modulus 60 to get the leftover number of seconds. Let me try to explain what that is. Let's say we had 140 seconds. Well, we do modulus. Remember, it's a type of division, but instead of the quotient, we get the remainder. Do mod 60. 60 goes into 140 two times, but we're ignoring the quotient. We just want what's left over. 140 minus 120, because that's 60 times 2, leaves 20. Our leftover seconds are 20. What that means is all the rest of the seconds make up a whole minute. In this case, with 140 seconds, that would be 2 minutes. And the remainder, 20, is the number of seconds that are left over that don't divide evenly into a full minute. So we would have here 2 minutes, 20 seconds. That's what the modulus operator will give us, is the decimal portion if it were a floating point number, or a remainder in this case of the integer division. The 20 seconds are what's left after we take out full 60-second groups, which represent minutes. And we continue this process. After we do the modulus 60, we then do a divide by 60. Because it's integer, it chops off those remainder seconds, in my example 20 seconds, but we've already captured that using modulus. So now we're going to get to total number of minutes. We don't usually use huge numbers of minutes, so we're going to now do modulus 60. I'm sorry, divide by 60 to get the number of hours. Mod 24 for the leftover days. That'll be some hours left over, and then the number of days. So this process of doing a modulus and then a divide with integers allows us to easily compute the number of seconds, minutes, hours, and days. And if you wanted to carry it on months, years, having to take into account leap years, a number of sites on the web that will show you how to take a number of days and figure out the leap years from it so you'd know exactly how many years, etc. The point being, this is a very complicated way to deal with time. Seconds, minutes, hours, days, very complicated because of all the rules. But dealing with time in just straight old seconds or milliseconds, since epoch time, allows us to use an integer and compare it to other integers, or subtract an amount, add an amount, and very easily compute time. It's very practical.